Hello class, and welcome to section 9.6, which is about the powers of monomials. By the end of today's lesson, you will be able to identify and use the different rules for powers within monomials. Our first rule is going to be power of a power. So this happens when an exponent is raised to another exponent. So as you can see right here, there's an exponent and then there's a second exponent. When this happens, you are going to multiply the two exponents to get the final answer. Reason being, this 2 to the fourth to the third power. What that actually means is 2 to the fourth times 2 to the fourth times 2 to the fourth. So that's what that actually would work out to be, which then, as we know, would then break down into 2 times 2 times 2 times 2. That would be our first group. And then times 2 times 2 times 2 times 2. That would be our second group. And then times 2 times 2 times 2 times 2. That would be our third group. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 2's being multiplied, or 2 to the 12th power. Now notice, instead of writing it out the long way, or the even longer way, we can just take and multiply those exponents to get us our exponent of 2 to the 12th power. Couple more examples of this. We've got, for this first one up top, we've got n to the 7th to the 12th. So again, we're going to go through and we're going to multiply those two powers, which is going to give me n to the 84th. On this bottom one, I have 7 to the third to the negative fourth. So I'm going to multiply my powers, and I'm going to get 7 to the negative 12th. Now, as we learned in the last two lessons, we don't want negative exponents in our answer. So we're going to have to finish this out by pushing that to the denominator, so 7 to the 12th to make it positive, and then we have just a 1 up top, so 1 over 7 to the 12th power. Go ahead and try this one on your own. So going through, we do 6 times 2, which is going to give you 9 to the 12th power. Our other rule that we have today is going to be the power of a product rule. So this is when a product, or things being multiplied, is being raised to a power. Then you have to distribute the exponent to each separate piece. So what this means is right now I have 2 times x to the 4th power. What that means is that when I when I raise this to the 3rd power, I'm going to have to distribute this exponent. So the long way, if I wrote this out, it would look like 2x to the 4th times 2x to the 4th times 2x to the 4th, which if I wrote that out the even longer way would give me 2x from the first part times 2x from the second part times 2x from the third part. So what that actually means for our answer then is we have 2 to the 3rd power, 1, 2, 3 2's, and x to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12th power. Now notice, over here, my 2 didn't have an exponent. So when the number doesn't have an exponent, that just means there's one of them. So 3 times 1 gave us the 2 to the 3rd. And then we had 4 times 3, which gave us the x to the 12th. Now this is not actually our final answer because if you have more than one thing, you want to simplify it as much as possible. So 2 times 2 times 2 actually gives us 8x to the 12th power as our final answer for this one. So again, each piece has to be treated as its own entity, and each entity needs the exponent because each part is going to be repeated. So in this next example, I've got negative 4 s to the 7th r to the 5th, all raised to the 3rd power. Again, remember, that number, if it doesn't have an exponent, has an exponent of 1. So this is going to start as negative 4 to the 3rd power. Remember, negative numbers should be in parentheses. And then you have s to the 7 times 3, which is going to be 21. And then r to the 5 times 3, which is 15. Now we're going to want to solve this front part. So negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is going to give me negative 64. And then we've got s to the 21st, r to the 15th. So that would be my final answer on this one. On my next one, I've got 3x to the negative 2nd, y to the 4th, and all of that to the 2nd power. So I'm going to say, again, the 3 has a 1 on it. So instead of 3 to the 1, it becomes 3 to the 1 times 2, which is 2. Instead of x to the negative 2nd, it's going to become x to the negative 2 times 2, which is going to be x to the negative 4, and then y to the 4 times 2, which is 8. When I simplify this then, I'm going to say, okay, 3 to the 2nd power is 9. So I've got 9x to the negative 4th, y to the 8th, but I have that negative exponent in there, so that's not okay. So I'm going to finish that out by saying 9 is a positive exponent. That's going to stay up top. X to the 4th goes to the bottom, and then y to the 8th stays up top. So we got 9y to the 8th over x to the 4th. Go ahead and try this one on your own. Distribute that 2, we end up with 5 to the 2nd, a to the negative 4th, and b to the 14th. Rearranging and moving things around, we end up with 25b to the 14th over a to the 4th. Last thing we're going to do, everyone's favorite, a couple of word problems in here. So the first one, we've got the radius of a viewing area in a microscope is 9.2 x to the 3rd, y to the negative 4th centimeters. Find the area of the viewing field if the formula is 3.14 times radius squared. So we need to apply this. It tells us that the radius is 9.2 x to the 3rd, y to the negative 4th. So that's going to have to go in that radius spot. So I'm going to start by saying area is equal to 3.14. And then in parentheses, I've got 9.2 x to the 3rd, y to the negative 4th. And then that is squared. So we have that whole thing, which is the radius, that whole thing is squared. We want to make sure that we put those parentheses around that so that it doesn't look like there just is an exponent floating out there. So make sure you have that parentheses. Next thing we're going to have to use that distributive property of exponents. So bring that on into each of the pieces out here. It doesn't go to the 3.14 because the 3.14 is not being squared. It's not in the parentheses. So we got 3.14 times 9.2 squared times x to the 6th, and then y to the negative 8th. Next thing we're going to solve is that 9.2 squared. So I've got area is equal to 3.14 times 9.2 squared, which is going to be 84.64. So 84.64 after you type that into the calculator and square it, and then you've still got your x to the 6th and your y to the negative 8th. Next thing I'm going to do is now I'm going to deal with that 3.14, and I'm going to multiply that out. When I do that, I end up with an answer of area is equal to 265 and then it says 7696, so I'm going to go 7, and then since it says 6 next, and then a 9 after that, I'm going to round that up to a 7, and then I've got x6, y negative 8. Lastly, I have that negative 8. We don't want negatives in our final answer, so I'm going to say my area is equal to 265.77 x to the 6th over y to the 8th power. And then I'm going to put my label on there, which in this case is going to be centimeters squared. So I know it looks weird that we don't have an actual final answer here, but we have this formula that would give us the answer once we know what x and y are. I want you to go ahead and try this problem to find the area of a square with side length 7a to the 8th, b to the 2nd. I want you to try this one on your own. So the area formula for a square is going to be x squared, where x is the side. So if my side is 7a to the 8th, b to the 2nd, I'm squaring that whole thing, which gives me 49a to the 16th, b to the 4th. If you have any questions about this or anything else from the lesson, please feel free to contact me and I will help you as soon as possible.